ওকে স্যার, ওকে স্যার, ঠিক আছে স্যার।
So let we come again. So this is seasonal autoregression of order 2. Now, so this is one way to understand or to decompose the seasonal part and non-seasonal part in additive form. This is the non-seasonal part, this is the seasonal part. There is another way to express the actual seasonal time series variable in autoregressive process in a multiplicative form. Why it is additive form? Because we have just added the non-seasonal autoregression to seasonal autoregression. This is the non-seasonal autoregression, this is the seasonal autoregression, and we have added them together to express the autoregressive part of the actual time series yt. The alternative way is to express the autoregressive process in a seasonal time series in a multiplicative form. Multiplicative form means the non-seasonal part into seasonal part. Just look at the expression we have provided here. 1 minus phi 1 L, L for lag operator, into 1 minus phi 1 S, L to the power S, yt is equal to epsilon t. Okay. Now try to multiply the left hand side. Left hand side ke multiply koro. একটু ভেঙে নাও জায়গাটাকে টু রিচ হেয়ার। এখানে কি করে আসছি সেটা বোঝার জন্য এটাকে প্রথমে মাল্টিপ্লাই করে নাও। মাল্টিপ্লাই করলে আমরা চারটে এলিমেন্ট পাবো আফটার মাল্টিপ্লিকেশন। ফার্স্ট টার্ম উইল বি yt, সেকেন্ড টার্ম উইল বি মাইনাস phi 1 L yt. Minus phi 1 L yt means phi 1 into yt minus 1 after taking it in the right hand side. Similarly, if you multiply this term into this term, phi 1 S yt minus S, L to the power S means t minus S. And you have the cross multiplicative terms, that is phi 1 L into phi 1 S, L to the power S into yt. So from here you have this component phi 1 into phi 1 S yt minus S minus 1 plus epsilon t. So if we express autoregressive process in multiplicative form like this, we have additional term here, phi 1 into phi 1 S yt minus S minus 1. That is, this is the interaction of non-seasonal component as well as seasonal component. So if we express autoregressive process in seasonal time series in multiplicative form, we have shown the result by taking only autoregressive of order 1 1 to understand the process clearly. You can extend this model for higher order autoregressive also. So for 1 1 model,
Sir, Mouli is waiting. Sir, Mouli is waiting.
yes, yes. So for 1 1 model, autoregressive of order 1, autoregressive of order 1, seasonal, non-seasonal, if we express it in multiplicative form, we have purely autoregressive part for the non-seasonal, autoregressive part for the seasonal, as well as the interaction of seasonal and non-seasonal component of the autoregressive part. So this is the additional term we have to interpret this term if we express the seasonal autoregressive process in multiplicative form. So in a multiplicative form, the autoregressive term in lag 1 is allowed to interact with the seasonal autoregressive effect at lag S, this part. Okay, so we are considering lag 1. So non-seasonal component and seasonal component, this is the interactive part. So we have better explanation, better interpretation if we express autoregressive process in multiplicative form. Now let we expand the order of autoregression. Seasonal autoregressive process of order PP. Small p, capital P. Small p denotes autoregressive of order in non-seasonal part. Capital P denotes the autoregressive order in the seasonal part. S is the seasonal dimension. So you have to keep in mind, to express autoregressive process in seasonal data, we actually need 3 elements. One is the order of autoregression in non-seasonal part, order of autoregression in seasonal part, and frequency of the season. Okay, so in general, we can denote it SAR PPS. In the case of annual time series, we have denoted this part in this way, simply ARP, autoregressive of order P. But in the case of seasonal autoregression, you need to denote it SAR of order PPS, autoregressive of order P in non-seasonal part, autoregressive of order capital P in seasonal part, and the seasonal frequency S. So in terms of autoregressive polynomial, I have already mentioned at the starting point that we need to keep in mind how to express the autoregressive process, how to express the moving average process in terms of their polynomial function. So here we have used it. So SARPP, so phi P of L, this is the autoregressive polynomial of order P for the non-seasonal part, and phi PS L to the power S, this is the autoregressive polynomial of the seasonal part. So autoregressive polynomial of non-seasonal part, autoregressive polynomial of seasonal part. That is phi P of L, you can expand phi P of L in this way, 1 minus phi 1 L minus phi 2 L square minus phi 3 L cube, etc. as we have in case of our annual time series. I have already explained earlier. But this part is the new. Phi PS L to the power S. Phi PS L to the power S could be expressed in this way. 1 minus phi 1 S L to the power S minus phi 2 S L to the power 2S, phi 3S L to the power 3S, etc. So if you have monthly time series, so it is L to the power 12, that is 12 month back, L to the power 24, that is 24 month back, L to the power 36, that is 36 month back, etc. Okay. Similarly, we can think about the moving average process. So before moving into moving average process, let we try to clear our concept, the autoregressive process. So we can generalize the autoregressive process in this way. So we can use AR process of order 1-1 either in this form or AR process of order 1-1 in this form. This is the additive form. This is the multiplicative form. Okay, so in the autoregressive process, our basic task is to analyze the nature of stochastic behavior, because you have expressed seasonal process in autoregressive form because you are assuming that the seasonal process is stochastic. Now your task is to analyze the nature of stochastic behavior. That is, nature of stochastic behavior means whether it is stationary or non-stationary, whether it contains unit root or without unit root. So in the case of a seasonal time series, as we have, there are two types of autoregression, non-seasonal, seasonal. In terms of unit root, we also have two types of unit root. One unit root relates to the non-seasonal part. That is the conventional unit root we have in the case of annual data. Another unit root relates to the seasonal part. So if we analyze the seasonal behavior of a particular time series, so a seasonal behavior or a seasonal process of a time series contains unit root if this coefficient of the AR1 process equal to 1. So AR1 process in seasonal terms means y minus y of t minus 1s, not y t minus 1, y t minus 1s, that is y t minus 4 for quarterly, y t minus 12 for monthly, y t minus 52 for weekly, y t minus 24 for daily data, y t minus 7 for weekly data. So y t minus 7 indicates AR1, y t minus 24 indicates AR1 for hourly data, y t minus 12 indicates AR1 for monthly data, y t minus 4 indicates AR1 for quarterly data, y t minus 52 indicates for weekly data. So in this way, we have to concentrate on whether the value of phi1 is equal to 1, indicating the presence of unit root in the seasonal part, because we have already shown in the case of non-seasonal time series analysis that presence of unit root is equivalent to the value of coefficient of yt minus 1 is equal to 1. Phi1 is equal to 1 in AR1. You have to keep in mind, in AR1 only, if you have AR2, in that case, the coefficient of yt minus 1 is equal to 1 do not imply the presence of unit root. So the value of this coefficient equal to 1, that is the value of yt minus 1 in the case of non-seasonal part, indicates unit root only for AR1. Similarly, we can apply the rule in the case of seasonal part also. So if the coefficient of AR1 component means different in the seasonal part. AR1 component means the coefficient for yt minus 4 or the coefficient for yt minus 12 or the coefficient for yt minus 52 or the coefficient for yt minus 24 or the coefficient for yt minus 7, depending upon the frequency of seasonality. Okay, so we have to concentrate on this part and concentrate on this part to finding out whether the stochastic behavior in your data. So stochastic behavior in a seasonal time series means stochastic behavior in the non-seasonal part as well as the stochastic behavior in the seasonal part. So we have to look at the stochastic behavior simultaneously by considering seasonal and non-seasonal part. So there are two ways. One is to look at the behavior in additive form. Another one is to look at the behavior in multiplicative form. Clear? So now we can stop for today. Now we can analyze the, yes, we can discuss.
স্যার বলছি যে এইখানে